So it's been a long time taking any video solutions to VCAR past the exam. And finally, I'm back. Well, this time I'm going through the 2021 Specialist Math exam. Happened in Northern Hemisphere timetable. Right, so let's have a look. Question 1, 4 marks. Consider the function f with root f of x equals x squared over 2 plus sine x. Find all values of x for which the second derivative is equal to 0. So the derivative of f is basically 2x over 2 plus cosine of x. And f double dash of x is, we simplify it a bit, 1 minus sine of x. And we need to equate that to 0. So we have sine x equals 1. But remember, without any further restrictions, we assume that x are all real numbers because for half x squared, that's a cubic, the implied domain is real numbers, and sine x has the maximal domain, all real numbers as well. So we are looking for a general solution to that equation, which starts from half pi. Maybe we can do half pi plus 2 pi because the period of sine is 2 pi. Or we can do half pi plus 4 pi, etc. But we can also do half pi minus 2 pi by the periodicity property of sine function or cosine function. Therefore, I will generalize the solution as half pi plus 2k pi. K is all integers, okay? Including 0. The next one, explain whether the graph of f has any points of inflection. It's very tempting for us to say, okay, since we have infinite number of solutions from previous part, we have infinite number of points of inflections. But that's not the case here, because if you consider the sufficient condition for a graph to have a point of inflection, we must notice that the graph has changes in its concavity. What that means is, if a graph looked like that, yes, it has changes in its concavity, but the condition for changes in concavity is the sign change in second derivative. So let's look at the graph of the second derivative. The second derivative, I believe, is f double dash x equals 1 minus sine x. And it should look like that. If I'm not mistaken. And I can duplicate that pattern infinitely, left or right. So if you want to say, okay, yes, this graph indeed touches the x-axis infinitely, but is there any sign changes? Of course not, because along the graph, it's always positive or 0. It has nowhere negative. So I would say f of x has no point of inflection, as f double dash x do not change sign. Which implies no change in its concavity at points x equals half pi plus 2k pi, where k is all integers, okay? No points of inflection and appropriate justifying with reasoning, okay? So let's look at the next one. An object of mass 10 kilograms over a horizontal plane is acted upon by a constant force of magnitude p newtons and a horizontal resistance force opposing the motion that has a magnitude equal to 1/4 of the magnitude of the normal reaction force. So basically, I would say the friction force is just 1/4 of normal force. As the result, the object accelerates horizontally at 2 meters per squared second. Find the value of P in terms of G. Okay, finally we have this phrase, in terms of G, if P acts horizontally. So let's do a quick sketch. This is a horizontal plane. And here is a box, or we say an object. The gravitational force is 10G. And we have a normal reaction force perpendicular to the horizontal plane. Let's say it's N, okay? Opposing the horizontal movement, we have the friction force. Let's say F is 1/4 M. And if P acts horizontally, I would say, okay, it's here. So this is my P. My acceleration is to the right direction. Let's assume A equals 2 meters per squared second. So now, vertically, we have the normal reaction and the 10G are in equilibrium. Horizontally, we have P minus 1/4 N equals 10 times the acceleration. So P minus 1/4 times 10G equals 10 times 2 meters per square second. So P minus 5G over 2 equals 20. And P is just 20 plus 5G over 2. We could simplify that expression, of course, but it's up to you because it's already in terms of G. So I would say it's 40 plus 5G over 2. Take out 5, 8 plus G over 2. And that's in newtons. Okay? Then we want to find the value of P in terms of G if P acts at an angle of 30 degrees upwards from the horizontal. So let's assume nothing else changed except for the direction of P. Basically, I'm going to duplicate this force diagram here, but only one variation, which is the direction of P. The force P here is now 30 degrees upwards. So let's change the direction of this arrow here. Much better. So this is 30 degrees. Looks like we need to break P into two pieces, in vertical and horizontal direction. Let's use dashed lines to avoid any confusion because these are two force resolute. So this bit is P cosine 30 degrees, and this bit is P sine 30 degrees. But here, I won't use the letter N as in previous part again, because now my N, the normal reaction, is no more 10G. It's actually 10G minus P sine 30 degrees. So I'm writing R instead of N. And my friction here should be F2, a different friction force in different case. This will be 1/4 R, which is the new reaction force. Now we can say vertically, yes, it remains equilibrium because it only accelerates to the horizontal direction. We have R plus P sine 30 degrees equals 10G. So now we have horizontal one. Yes, in horizontal direction, the object is accelerating at 2 meters per squared second. So we have P cosine 30 degrees minus a quarter R equals 10 times 2, which is 20. And we have equation 1 and equation 2. Now let's try to find the value of P. In this equation, or this system of two equations, we have two letters, R and P. So we just need to find the value of P, which means we need to eliminate the letter R. Let's look at the second equation. If you take a look at the coefficient here, it's a fraction. We are not happy with the fraction here, so we just multiply equation 2 by 4 to obtain 4p times half root 3, which is cosine 30 degrees, minus r equals 20. And that's my equation 3. So now we can compare this guy here and this guy, which means when we add them up, we can eliminate the letter r. So equation 1 plus equation 3 will be 2 root 3p from this term here minus r plus normal reaction force r plus p times half equals 10g plus 20. Don't forget to add everything on right-hand sides. And we should have p out 2 root 3 plus half equals, let's say it's 10g plus, hold on a second, we made a mistake here because we haven't multiplied the 20 by 4, which is 80. That doesn't look right, so we need to fix it up. So this is 80, this is 8. Okay, much better. Okay, to simplify that expression further, I would say, okay, I take out a half here, 4 root 3 plus 1 equals 10 lots of g plus 8. And remember, we remain our answer in terms of g, okay? Now p times 4 root 3 plus 1 equals 20 g plus 8. So therefore, my p-value will be 20 g plus 8 in a bracket divided by 4 root 3 plus 1, okay? Because the question hasn't specified any required form, I would say, let's do some basic arithmetic here, learned in year 10 and year 11. Multiply both the top and the bottom by the rational, actually third conjugate of the bottom. So we will have 20 lots of 4 root 3 minus 1, g plus 8. And the bottom should be 4 root 3 is root 48 because it's root 16 times root 3, okay? So the square of 4 root 3 minus 1 squared is 48 minus 1, which is 47. And we have our bottom 47. This guy here has unit newtons, okay? So that's a mechanics question. And let's look at the next one. Let x be a binomially distributed random variable with n equals 4 and p equals half. Okay, x is a binomial distribution, n equals 4 and p equals half. And y is also a binomial distribution with n equals 4 and p equals half. X and Y are independent random variables. Let Z be the random variable defined by Z equals 2x plus 3y. So find the mean of Z. Basically, the mean of Z is the expected value of 2x plus 3y. And expanding the expected value, we will get 2ex plus 3ey. But we haven't got ex and ey yet, so we need to recall some basic knowledge from math method. If x or y are binomial distributions, the expected value is just the number of trials multiplied by the probability of success, which means it's just 4 times half equals 2. Expected value of y is another n times another p, so it's just 6. This guy is 6 here. 6 times half equals 3. So it will give you 2 times 2 plus 3 times 3. 4 plus 9 equals 13. And that is my total mean for the combined variable z. Then we need to find the standard deviation of z. So recall that variance ax plus by is a squared variance x plus b squared variance y. My a value here is 2, so a squared is 4. 4 lots of variance x plus 9 lots of variance y, because b is 3. For binomial distributions, the variance is given by np times 1 minus p, so it's 2 times half, which is 1. Variance y is np 1 minus p, so it's 3 times half equals 3 on 2. And therefore, it will give you 4 times 1 plus 9 times 3 over 2. So it's 4 plus 27 over 2. We can't just leave the answer like that for the variance. We have to combine the integer and the fraction into one piece. In this case, I will write 2 at the bottom, 8 plus 27, which is 35 over 2. However, we need to take a closer look at the question requirement. We need the standard deviation instead of the variance. So variance z is 35 over 2. The standard deviation of z is the square root of variance. So it's root 35 over 2, which gives you root 35 over root 2. Rationalizing the denominator gives us root 70 divided by 2. And I don't think we can expand root 70 any further. So this will be our final answer to part B. So let's take a look at the next part. Consider the function f from -1 to 1. F of x is cosine inverse x minus half. So if we recall the basic shape of cosine inverse, it has a maximal domain from -1 to 1, and it's strictly decreasing. Its range goes from 0 to pi. But now it has been shifted by half pi units downwards, which means I need to shift that graph downwards like that. So now the graph should have the endpoints, I mean the y values, negative half pi to half pi, okay? All right, sketch the graph of f on the axis below, labeling the endpoints with their coordinates. So remember, pi is approximately 3.14, blah, blah, blah. So half of that will be approximately 1.57, which is roughly 1.6 something. So minus 1, half pi is roughly here, and 1 minus half pi, which is the right hand point, is roughly here. Let's label them. We know the graph should roughly look like this. But actually, let me adjust that graph a little bit. You know this point, before we take in the inverse, it's actually the turning point on the cosine graph. So at this point, you should have a vertical gradient, okay? Now, with this point here, probably I'm going to adjust the concavity a little bit. So your shape should look like that. And near the only x-intercept 0, 0, you should notice the derivative of x is -1 over root 1 minus x squared. And f dash of 0 is definitely -1. So if you draw tangent lines through this point, does that have a gradient -1? Probably not, because this is our run here. This is rise. Rise is -1. So it is a good idea for us to adjust that a little bit. Much better. So you need to notice, if you draw a tangent line across these 2 points, the line should look like that, okay? And this is a point of inflection. So now sketch the graph of y equals absolute f of x on the axis below. Basically, I'm going to duplicate that graph. But notice that anything with an absolute value outside, you just flip in the negative parts over the x-axis while retaining any positive part, like this bit here. So I'm going to rub out this bit, but reflect that upwards. So now your graph should look like this. And a little detail here, it's a cusp, not a turning point, because the gradient from this point and the gradient towards this direction, they are not the same thing, okay? They're not approaching to a turning point, a zero gradient. So this point should have a coordinate to 1/2 pi, okay? If you want to sketch the graph of y equals f of absolute x, you just flipping the right branch to the left, okay? Basically with this existing original graph. I drop it here. The only part I need is this bit here, and I reflect that to here. I will get rid of this bit. So now let's adjust its concavity, okay? -1, -1/2 pi. And that's it. Okay, for the last bit, I will change the color to blue. What is that? I'll change the color to white. All good. And this bit should be drawn in red color. All right. So basically that is my graphing question. And let's look at question 5. Solve the differential equation dy dx equals 1 plus y squared over 1 plus x squared, given that y equals 1 when x equals 0. To show that y equals x plus 1 over 1 minus x. Normally in these sort of questions, I would just rule up the page to properly use all possible spaces in the paper. So let's do a separation of variable. Dividing 1 plus y squared through. And multiplying the x to both sides. But I don't leave the differentials on both sides without integrating first. So the left-hand side will be tangent inverse y. The right-hand side will be tangent inverse x plus c, okay? For these type of questions, you have to make sure you put at least one c, okay? X equals 0, y equals 1. So the left-hand side is tangent inverse 1. The right-hand side is tangent inverse 0 plus c, which will give you pi on 4 equals c. So tangent inverse y equals tangent inverse x. It's a bad idea to squash everything in one line. Let's move to next line. Plus pi on 4. Finally, the given answer is in terms of y. So I'm going to copy everything here. But now I want to make y, the letter y, as my subject. So I'm going to take tangent to both sides of the equation. And then we know tangent inverse x is just x for all x as element of real numbers. So now I will just get y equals tangent inverse this guy here. Now it looks like tangent A plus B. And we need to use double angle formula, or actually compound angle formula, to expand the given expression. So I'm going to write tan tangent inverse x plus tan pi on 4 as my tan A plus tan B. If you take a closer consultation to your formula sheet, the bottom will be 1 minus the product of two tangents, okay? Which should look like that. So the bottom will be x plus tangent pi on 4 is 1. The bottom will be 1 minus x times 1, which is x plus 1 over 1 minus x. And my left-hand side is y. It's a good place to write QED here. I finished the show that part, and then we want to find y 1 over root 3 in the form of a plus root b. So y of 1 over root 3 is just 1 over root 3 plus 1, using the result we just shown in the previous part. Now let's deal with the top first. We combine two parts in the top, which is 1 plus root 3 over root 3. The bottom will be root 3 minus 1 divided by root 3. So these two root 3's will cancel each other. And now it's time to write root 3 plus 1 divided by root 3 minus 1. It's not our required answer yet. So we need to multiply the top by root 3 plus 1 and the bottom by root 3 plus 1. Too much rationalizing the denominator as if we are doing a year 11 exam. Okay, so the top will be root 3 plus 1 squared divided by 3 minus 1. 3 plus 2 root 3 plus 1 over 2. And this should be 4 plus 2 root 3 over 2. The answer in most simplified form will be 2 plus root 3. Okay, so that's it. And let's have a look at question 6. Find the values of a and b for x squared, x cubed times y plus ay squared equals b, given that the tangent to the graph of the relation at 1, 1 has the equation 4x plus 5y equals 9. So, typically implicit differentiation from x cubed times y plus a times y squared equals b. Product rule, u dash is 3x squared times v plus v dash, which is dy dx, times u, which is x squared, plus a times the derivative of y squared is 2y, but y is a function of x, so we need a dy dx afterwards. B is a constant, so it gets you 0. So now we have 4x plus 5y equals 9. It's the tangent line, but not in y equals mx plus c form. So 5y is just minus 4x plus 9. And the y should be minus 4x over 5 plus 9, which means my gradient of tangent is minus 4 over 5. And it is the value of derivative dy dx at point 1, 1. All right, so we can substitute the given point x equals 1, y equals 1, and the value of the gradient to the differentiated equation. So we have 3 times 1 times 1 plus minus 4 over 5 times 1 plus a times 2 times minus 4 over 5 equals 0. And a 3 minus 4 over 5 minus 8a divided by 5 equals 0. These two will be 15 over 5 minus 4 over 5 equals, I transpose 8a on 5 to the right-hand side. So 8a to 5 equals 11 to 5. 8a equals 11. My a value will be 11 over 8. So that is my value of a. But we also need the value of b as well. So put a equals 11 over 8 back in the relation. We have x squared times y plus 11 over 8 y squared equals b. So now we only need to find b by substitute x equals 1, y equals 1. So 1 plus 11 over 8 equals b. Because 1, 1 is a point on that relation. If I substitute that point, the x, y values into the relation, it will satisfy that LHS equals right-hand side. Left-hand side equals right-hand side, okay? Very easy. So 19 on 8. So let's take a look at next question. A particle moves in a straight line, so the acceleration is that guy here. Where is displacement from fixed origin is x meters. Okay, so if the velocity is 4 when x equals 0, v is given greater than 0. In meters per second, we want to find the velocity when x equals 2. So acceleration equals d dx half v squared 5 plus 6x. Integrating both sides, I would say 1 times d half v squared equals 5 plus 6x dx. Let's say if x, hang on a second, if v equals 4, x equals nothing. If v equals an unknown, let's say vs, x equals 2. So why don't we implement these two boundary conditions in our previous integral? So the left-hand side, when anti-differentiated, will be half v squared, evaluated from 4 to vs. And the right-hand side will be 5x plus 3x squared from 0 to 2. So half vs squared take away half times 4 squared equals 5 times 2 plus 3 times 4 minus 0 plus 0. So half vs squared minus half times 16, 8, 10, 12, 22. So half vs squared equals 30. Vs squared is 60. Vs is greater than 0 as given. Vs should be square root of 4 times 15. That's 60. So Vs is 2 roots 15 meters per second. That's it. Ooh, that looks like something in the past. A question in Q-Baha exam 1? Probably. I may have a vague impression on certain questions. All right, let's look at question 8. Find the volume of the solid of revolution formed when the graph of that from 0 to 1,6 is rotated about the x-axis. V around x is pi integral 0 to 1,6 y squared dx, which should be pi from 0 to 1,6, 36 divided by no square root, which is 1 minus 9x squared dx. Don't forget your dx, okay? It's part of the integral. I know it's very tempting to just write, okay, 36 divided by minus 9 log e something, but that's not the way we should work through. That's not the way it works. So we have to do partial fraction, okay? Ooh, partial fractions. 36 over 1 minus 3x, 1 plus 3x. This will be a over 1 minus 3x plus a constant b over 1 plus 3x. We can do 1 plus 3x, 1 plus 3x here, and 1 minus 3x and 1 minus 3x here. Common denominator, okay? So we can now equate the numerators on left-hand side and right-hand side. Okay, so now we can take some special values to find a and b. Let's say x equals 1 over 3, so 36 equals a 1 plus 3, okay, 3 times 1/3, which is 1. So 2a is 36, a is 18. Now we can also take minus 1 over 3, so 36 equals b, because that term will disappear. 1 plus 1 as well. Minus 3 times 1 over 3. Okay, so b value is 18 as well. Okay, looks like we occupied too much space with the partial fractions. Let me make them smaller. And we put the partial fractions back inside the integral. So now we have 18 over 1 minus 3x plus 18 over 1 plus 3x. Remember, we have our formula 1 over ax plus b dx is 1 over a log e absolute value ax plus b plus c. Definite integrals, we don't need plus c behind, so we just say 18 over minus 3 log e absolute 1 minus 3x plus 18 over 3 log e 1 plus 3x 0 to 1 6 minus 6 log e 1 minus 3x plus 6 log e 1 plus 3x 0 to 1 over 6. Before I do any evaluation, I need to combine them together. 6 out, log e 1 plus 3x over 1 minus 3x. 6 pi is the coefficient, 1 6. 1 plus 3 times 1 6 is 1 plus half, which is 3 over 2. 1 minus 3 times 1 6 is 1 minus half, which is half. That guy divided by half will be 3. So log e 3 minus, if I substitute 0 here and here, that will be log e 1. Get rid of that because that's 0. So the final answer is 6 pi log e of 3 units cubed. Not a bad question. Simple and easy. Question 9. Show that d dx secant of x is secant x times tangent x. Well, I know some of you might already memorize that formula, but now you need to show basic derivations. So basically, I'm going to use that shortcut here. Well, it's a shortcut, but you have to show how you derive the answer. It's 1 over g of x. The derivative of that is minus g dash of x divided by gx whole thing squared. So basically, the secant x dx is just 1 over cosine of x. And by that shortcut version of chain rule, you will have minus sine x divided by cosine x whole thing squared. So now you can break that into two pieces, which is sine x over cosine x by itself times 1 over cosine x by itself. The first bit, you must be very familiar with that, tangent x times secant x. So rewrite that into the required, the desired form, the order, secant x tangent x. The next part is basically using the log e g of x dx. That is g dash over g. For any specialist math student, you must be very familiar with that, even including mathematics students. So let's say d dx log e of secant x plus tangent x. The inner function is just this guy here. So now we take care of the derivative of the inside. The derivative of secant x is here, secant times tangent. That's for the first term. The derivative of tangent x is secant squared x. As given in your formula sheet, you can take a look at the basic derivatives. And then I just take out the common factor secant x. What's remaining inside the bracket will be tangent x plus secant x. And then the whole thing is divided through by tangent x plus secant x. with this step here, it is clearly shown the result is secant x, okay? So in the actual exams, you need to pay attention to the little words like hence, and also try to use the result from previous parts if it's available. So now we are guided towards part C. Find the length of the curve y equals log e secant x for the interval x goes from minus pi on 3 to pi on 3. Length of the curve has the formula a to b square root of 1 plus dy over dx squared dx. So now we are going to find dy dx first. Log e secant of x. The derivative of that will be 1 over secant, but remember you have to multiply 1 over secant by the derivative of secant. So it's secant x tangent x from part A. So now your dy dx is just tangent x. Before I do the substitution, I would like to write the expression for 1 plus dy dx squared. So 1 plus dy dx squared is 1 plus tangent squared x. What is that? Take a look at your formula sheet. It's secant squared x. Very easy. So the arc length is just minus pi over 3 to pi over 3 square root of 1 plus dy dx squared dx minus pi over 3 to pi over 3 secant squared x dx. I know square root of a squared is absolute value a, but if a greater than 0, absolute a is equal to a itself. If you take a look at the graph of secant, two asymptotes, x equals half minus half pi to x equals half pi. The actual domain is minus 3 pi to 3 pi to pi over 3, minus pi over 3 to pi over 3. So the effective path is highlighted in red. Lowest point is 0, 1. I guess secant pi over 3 is just 1 over cosine pi over 3, which is 1 over half, 2. So the range for this function is 1 to 2. Why am I discussing that? Because I'm going to eliminate the absolute value and make our life easier in the later calculations. By the way, finding that integral means we are looking for the area under the curve, and we can see the region is symmetrical about y-axis, or we say that is an even function. So I'm going to use symmetry. Two lots of 0 to pi over 3 secant x dx by symmetry. If I take a look at previous part, the derivative of that guy is secant x. So the antiderivative of secant x is that guy. Okay. Make sure you transcribe, you copy everything clearly and correctly. Zero to pi on 3. So now it looks like we can substitute pi on 3 into the antiderivative. Okay, minus 2 log e secant nothing plus tangent nothing. All right, so it's 2 log e. We already calculated secant pi on 3, which is 2, plus root 3. Minus secant 0 should be 1. So minus 2 log e 1. And this is nothing. So the answer is 2 log e 2 plus root 3. Of course, it may have different versions, but the question did not specify the required form. So I would guess this one will be acceptable. Or if you want to go one step further, I don't mind. 2 plus root 3 squared. That should be okay. Or you can expand it that a little bit. 2 squared is 4. Root 3 squared is 3. 7 plus 2 times 2 times root 3. 4 root 3. Okay? Etc. etc. Anyway, let's look at the next question. Find a where root a is real number given that square root 1 plus I root a plus root 1 minus I root a equals 2a. That's the last question. That's handy. So to get rid of square root, let's do it this way. Square both sides of the equation. So I will have square root 1 plus I root a squared plus 2 lots of something plus something squared. The right-hand side is very easy, just 2a itself. Okay, so basically this is my complete square formula. And I just need to fix some minor details. Bear with me. This is minus I, this is minus I. Okay, so now we can just directly get rid of the square root. 1 plus I root a plus 2, everything under the square root. 1 plus I root a, 1 minus I root a, plus 1 minus I root a equals 2a. Minus plus, get rid of them. 1 plus 1 is 2. 2 plus 2 lots of square root. Okay, so 1 squared minus I squared root a squared equals 2a. And this should give us 2 plus 2 lots of 1 plus a. Minus 1 times minus 1 times a, okay? And this should be 2a. 2 square root of 1 plus a equals 2a minus 2. So square root of 1 plus a equals a minus 1. Square both sides, 1 plus a equals a minus 1 squared, which is 1 plus a equals a squared minus 2a plus 1. A squared minus 3a is nothing, so a minus 3 equals 0. We could have a equals 0 or a equals 3. Do we take both? Check. If a is 0, left-hand side is square root 1 plus square root 1, because these two will be disappearing. That's 2. Right-hand side equals 0, which is not equal to left-hand side. Therefore, a equals 0 rejected. That is the only answer, I believe. A equals 3 only. If A equals 3, how do we verify if it's true? So let's rewrite the equation. Square root of 1 plus I root 3. Hold on a second. Let's write it in this way. Okay, A equals 3. Left-hand side equals 1 plus I root 3. Half plus 1 minus I root 3 half. Not very easy to compute. Let's use polar form. 2c pi on 3. Do a quick sketch. Root 3, 1, pi on 3. That's 2, okay? If it's minus, that's just 2c minus pi on 3 because they are conjugates to each other. Root 2c pi on 6 plus 2 root 2c minus pi on 6. Cosine pi on 6 plus I sine pi on 6 plus cosine minus pi on 6 plus I sine minus pi on 6. Root 2, root 3 over 2 plus half I plus root 3 over 2 minus half I. So this will be root 2 times root 3, which is, exactly 2a equals right-hand side. Yep, a equals 3 only. A nice complex number question. Testing your algebraic skills, basic algebraic skills. Overall, I would describe this paper, it tends to be on the easier side on the spectrum. Honestly speaking, comparing the past 20 years exam ones, I would say this paper should be the easiest one so far. All right, hopefully you guys find this video helpful. At the end, I need to make a disclaimer. This is just my personal suggestion with possible approaches to the past VCA exam. It in no way reflects the official opinions or endorsed by VCAA. And VCAA retains all the copyrights to the exam material. This video is only for non-profit pedagogical uses only. So, good luck with your specialist math learning, and I will see you in next video. Bye-bye.